Hello student, welcome to Memonit app. I am Muhammad Hasnan, a physics teacher at Memonit app. Dear students, today we will discuss the BPT2. What is the meaning of BPT2? The Brahmastra pre-pass test 2. In this paper, we will discuss about the chapter the electrostatics. So, dear students, before watching this video, we must clear your concept about your what is the basics concept that been used in the electrostatics, just like Gauss law, electric lines of force, electric field, and the what capacitance, potential. This type of concept you should know about this one, right? So without delaying, let us solve our questions one by one. So what is our first question? The first question is that a positive charge q is enclosed by a Gaussian spherical surface of radius a. If its radius is increased to a 4a, then the net outward flux will be, right? So dear students, by looking this question, what should be in your mind that there is some law is there. What is that? That is the Gauss law. So when I say what is Gauss law, you will say, sir, Gauss law is the electric flux through any closed spherical surface is given by q enclosed. Okay, this is by mistake. Q enclosed by epsilon naught, right? So what is q enclosed? This is the q enclosed, the charge inside the spherical surface. So when I draw the one spherical surface, and this is the qn. So what is the flux? Qn by epsilon naught. From this equation, one thing that I have been observed, that what is that the electric flux only depends on the what charge codes, charge enclosed. It is not depends on the shape of the what Gaussian surface or closed surface. So when the size of the if you increase the size of spherical what Gaussian surface, closed surface, then what will happen? The flux will remain same because our Q enclosed is not changing, right? So by this concept, what we'll observe, our fourth option will be the correct options, because it's does not depend upon the what shape of the Gaussian surface. Now okay, now come to the next part. So the question is, in the given circuit diagram, the resultant capacitance between P and Q is, right? So dear students, you must know about the series combination and the parallel combination of the capacitance, right? So when you look here, this is our C1, okay, this is our C2, this is our C3, and this is our C4, right? When you look the what, when you apply the what, the concept of series and parallel, what will you observe? The C1 and C2 in what, in series, and again C3 and C4 are in what, in series. So first, what is our first work? First we will find the equivalent capacitance of C1 and C2, and then we will find the equivalent capacitance of C3 and C4. So here what, 1 by C equivalent 1, right? C equivalent 1, right? This is by mistake, by this is a box. That is 1 by C1 plus 1 by C2. So what is the C1? C1 is 2, and what is C2? C2 is the 4. So after solving this, what we will get? The C equivalent 1 is equal to 4 by 3 microfarad. Similarly, we can also find the equivalent of C3 and C4, okay, by what is C3 equivalent? C 1 by C equivalent 2 is equal to what? 1 by C3 plus 1 by C4. What is C3? 1 by 2, and what is C4? That is the 1. After solving this, we will get 2 by 3. This is the C equivalent 2 by 3. Now this is the what, the equivalent capacitance. Now what happened? Now this C equivalent 1 and this C equivalent 2, now they are in the parallel, right? Now we have to again find the equivalent capacitance of this one. So this is the equivalent. So we have to find what, C equivalent 1 and C equivalent 2. So after putting the value of 4 by 3 plus 4 by 3, so After solving this, you will get the 2 microfarad, right? So our fourth option is the correct options. Okay. Now move to the next questions. That is the assertion and the reasoning basis. Let us first read the question. If a point charge Q is placed in front of an infinite grounded conducting plane surface, the point charge will experience a force. Now what is the reason? This force is due to the induced charge on the conducting surface which is at zero potential. Okay. So to find the force between the infinite charge conductor, grounded charge conductor and the charge. So grounded infinite charge, it means what? It implies V is equal to 0. This is the meaning of earth, right? Now here which concept is used? Here electric image concept is used here, right? So what we have to do? We replace the infinite plate with a image of Q which is at the distance of L from here. Okay, so this distance is what? L. So this is also L. So what is the total distance between the Q and minus Q? Here is the plus Q, okay, not minus Q, plus Q, and is the minus Q. This is the electrical image of Q, right? So what is the distance between them? This is the 2L. Now we will find the electrical force between the Q and minus Q. So after putting the values, what we get is the 1 by 4 pi epsilon naught into K square by 4 L square. So here is the what? The charge is minus Q and plus Q. So they are what? Attractive in nature. So if both assertion and reason are true, and the reason is the correct explanation of the assertion, so our first option is the correct options, right? Now move to the next question. So what is the next question? The electrical potential V at any point x, y, z all in meters in space is given by y V is equal to 4 x square volt. The electric field at the point 1 meter 1 comma 0 comma 2 meter in volt per meters. So dear students, here the relation between the electric field intensity and the potential concept is being to be used here, right? So we know the expression for electric field is given by E vector is equal to minus dou V by dou x I cap minus dou V by dou y j cap minus dou V by dou z k cap. Now we know the V is the value of V is given here, that is the V is equal to 4x square. Now put the values here at the place of V. So now after differentiating this one, the differentiation of this one what? 0, and this is also what? 0. So only with respect to x we get the minus 8x I cap. Now the question is that we have to find that at a point of 1 comma 0 comma 2. So at the place of x we put what? 1. After solving this we will get minus 8 I cap, right? So the electric field is what? Negative, and it is what? Along the negative axis. So our first option is the correct option, right? Now move to the next question. The question is that a charged dust particle of radius 5 into 10 to the power minus 7 meter located in a horizontal electric field having an intensity of 3.14 into 10 to the power 5 Newton per coulomb. The surrounding medium is air with the coefficient of viscosity eta is equal to 1.6 into 10 to the power minus 5 Newton meter square, second meter square. If the particle moves with uniform horizontal speed of 0.1 meter per second, neglect gravitational effect, number of electrons on it will be. In this question, there is a mixture of two concepts. One is the Stokes law and other is the force on the test charge, that is F is equal to Q. The concept is that this is the what electric field is, right? This is the electric field and the value of electric field is known, that is the 3.14 into the power 10 to the power 5 Newton per Coulomb. And this what a spherical dust particle is moving towards V, towards right with respect to V. So from the Stokes law, when the body moves in a fluid, then what will happen? A viscous force will act, and that viscous force will what? Opposite to the motion of the body, that is the viscous force. And we know that in the electric field, the charged body will also experience a force, and which force is what? Given by F is equal to Q. Since this is the positive charge, so force on this will be what? Along the direction of the electric field, that is the Fe. So this electric force and this is the viscous force will be equal. So the our is from Stokes law, what is viscous force? F is equal to 6 pi eta RB, and we know the electric force on the charge, that is the F is equal to QE, right? F is equal to QE, and we know the Q is equal to what? Q is equal to NE. So after putting the value of Q is equal to NE, we get what? F is equal to NEE. Now, so what this we will equate this equation 1 and 2, that is the F NEE is equal to 6 pi eta RB. So N is equal to what? 6 pi eta RB by A. Now substitute the all the values pi eta RB, will get value of N is equal to 30. So our first option will be the correct options. Think? Okay? Okay. Now move to the next question. The question is that 2 point charges repel each other with a force of 100 Newton. One of the charge is increased by 10% and others are reduced by 10%. The new force of repulsion at the same distance would be. We have to find the force. So here what? We have to apply which one? That is the Coulomb's law. So what is the, suppose this is charge Q1 and this is charge Q2, right? And distance between them is what? R. So we will say the F is equal to what? K Q1 Q2 by R square, which is equal to what? 100 Newton. Now case 1 is that what? The charge is increased by 10%. So new charge will be what? Q into Q1 into 10 by 100, that is the 1.1 Q1. Now other charge is what? Reduced by 10%. So we have to find what? New charge on that one, that is we have to what? Q2 minus Q2 by, and after solving this we get what? 0.9 Q2. Now the new force will be equal to what? FQ 1.1 Q1 into 0.9 Q1 Q2 R. Okay. Now put the value of K Q1 Q2 by R square. That is what? How much? That is the 100, right? Now putting the value of 100 here, and after solving we will get what? How much? F is equal to 99 Newton. So our which concept is the which option is the correct option? Our third option will be the correct options, right? Okay. Now move to the next question. The next question is that a capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of resulting system is. So here what? The concept is about the electrostatic potential energy, that is the energy is stored in the capacitors, right? So what is the initial condition? We have connected a capacitors with the battery. So when a capacitors is connected with the battery, so what is the energy? Energy will be what? Is stored in the capacitor will be what? Half CV square. Okay. Now what is in the next step is what is that? That is this capacitor is what? Connected with the uncharged capacitor, right? So what will happen? We know that after connecting the charged capacitor with the uncharged capacitor, what will happen? There will be the distribution of the charges. Okay. So after distribution of the charges, so charges will distribute until the potential of both the capacitors will be same. Means this is V before the connections. What? This is V. So after connection, the potential on this is what? V by 2, and this is what? B by 2 becomes V by 2 and V by 2, right? So This is the one concept. Second concept is that we have connected the two capacitors in parallel. So what is the C equivalent? The C equivalent equal to what? C1 plus C2. Since both are identical, so after solving this, we'll get the C equivalent is equal to 2C. So what is the energy after the correction? That is the half CVA square. C is what? 2C, and the potential is what? B by 2 square. After solving, we get what? U1 is equal to U by 2. So this implies it decreases by the factor of 2, right? So our first option is the correct option. Now move to the next question. The question is that what is the electric potential of the points A, B and C which are in uniform electric field, and we have to choose which one, the B, C and A, among which one has the maximum potential. So we know, as a students, we know that this electric field, and okay, and we know the relation between the electric field and the electric potential is what? dV is by d is equal to minus dr. So dV is equal to what? Minus E dot dr. So what does minus is indicates? It indicates that when we move in the electric field, then what? The potential will decrease. When we move in the direction of the electric field, then what? Potential will decrease. So it means what? This one with the at the higher potential, okay, this one means the potential has the what? Less than this one, and this one has the what? The potential less than this one. Means what? The potential of B is what? Greater, and after that what? Potential of C is greater, and after that what? Potential of A is the greater, right? Okay, so our which option is the correct option? We have to choose which one has the maximum. That is the B has the maximum potential at B, right? Okay, so now move to the next question. The question is that a charge of magnitude q is distributed uniformly on a solid sphere. The electric field at the point inside the sphere. Here the concept is about the Gauss theorem, right? We have to apply the Gauss theorem. Here is what? Here is the solid sphere, right? This is the solid sphere, and this is the radius r, right? So the 4 by 3 pi r cube volume of the sphere is what? How much charges? The charge is q, right? But we have to find the what? The electric field at the r. This is the what? Inside the sphere. This is the small r, right? So in this volume, how much amount of charge will be there? So in this volume, so how much charge will be there? This will be what? This will be q by, this will be what? How much? Q by 4 by 3 pi r cube into 4 by 3 pi small r cube. This is what? This is the rho. So this is what? Rho into 4 by 3 pi r cube. This is the new charge inside the what? New sphere. You can say q dash, right? In this the what? This is the new charge. Now apply the what? Gauss theorem. What is Gauss theorem? That is the E dot ds is equal to what? E dot ds is equal to what? Q enclosed by epsilon naught. So what is d dot is? That is the 4 pi r square. And what is q enclosed? This is the q dash by epsilon naught. Now put the value of q dash, that is the rho into 4 by 3 pi r cube by this 4 by pi r square epsilon naught. So after solving this, you get what? This one. So from this what we observe, that is the r is the concept, r is a constant, q is the constant, so a is directly proportional to r. So our third option will be the correct option, right? Okay, so it is clear? Yeah, good. Now move to the next question. The question is that a simple pendulum has time period t. The bulb is given negative charge and the surface below it is given a positive charge. The new time period will be. So the situation is like this, Okay, this is the electric field downward, right? Electric field is what? Downward. This is the positive charges. So what will happen here? The electric field what? Electric field will be upward, because this is what? Positive charge plate, right? So we know that this is the what? Electron. Then the force on the electron will be what? Opposite to the electric field. This is the downward force, right? And one force is also acting, that is what? Mg. So what is the net force acting on the electron? That is the mg plus QE by m. Okay, QE by m. This is the net force, not QE by m. This is the only m. Okay, this is the only QE. Okay, this is the net force acting on this one. So what is the acceleration of this one? That is g plus f by m. Okay, and f is what? G plus QE by m. This is the what? New acceleration, and we know that is the what? T is equal to 2 pi under root L by g. So what is the new time period? What? New time period will be equal to 2 pi under root L by g dash. So at the place of g dash, after putting, we get what? T is equal to 2 pi under root L by g plus QE by m. Since this is the extra factor, so what will happen? This time period will be what? Less. So hence T dash will be what? Less than is equal to T. So our first option will be what? Correct. Okay, got it? Yeah, good, very good. Now move to the next question, that is the question number 11. So what is the question is that there are three capacitors with equal capacitance. In series combination, they have a net capacitance of C1, and in parallel combination, a net capacitance of C2. What will be the value of C1 and C2? So this is what? This is the simple method. That is the series and parallel combination of the capacitors. So this is what? This is the first situation. This is the first situations, right? This is the C and C. So what is the C equivalent for this one? Tell me. This one is 1 by C equal to what? 1 by C plus 1 by C plus 1 by C, that is what? 3 by C. Now what is the second situation? The second situation is that they are all the three capacitors are connected in the parallel, this one. So what is the for this one C equivalent? This is the C plus C plus equal to what? 3C. So we have to find the ratio of C1 by C2. So we will divide C1 by C2, and after solving this we get what? C1 by C2 is equal to what? 1 by 9. So C1, the ratio of C1 to C2 is what? 1:9. So which option is the correct option? Our first option is the correct option, right? Got it? Yeah, very good. Now our next question is that what? Number 12 is what? A uniform electric field 100 voltmeter is directed vertically downward. Find the change in potential energy of electron whose height decreases by 0.5 meter, right? Okay, now come to this point. We have to use the concept of the relation between the potential and the electric field. We know already that is what? The relation between potential and electric field is what? dV is equal to minus E dot dr. Here what? Dr is given how much? 0.5 meter, and electric field is given what? 100 voltmeter. So after solving this will get what? dV is equal to 50 volt. Now one thing is that how can you find the potential energy? The potential energy what? Equal to what? Q into delta V. Okay, this is the way of calculating the electrostatic potential energy. So we know the value of dV, that is the 50 volt. So what is the energy of electron? That is the 50 electron volt. So which option is the correct option? The second option is the correct option, right? Now move to the next question. The question is that 2-point charges of plus 16 microcoulomb and minus 9 microcoulomb are placed 8 centimeter apart in air. Find the distance of a point from minus 9 microcoulomb charge at which the resultant electric field is 0. Right? Okay. Here the concept about the equilibrium, right? Equilibrium. This is the condition given here. Plus 16 microcoulomb charge is there, and distance of 8 centimeter. There is a one charge that is the minus 9 microcoulomb, right? So one concept is that if the both charges have the same sign, then electric field will be 0 between this one. Now here is what? Here the both the charges is what? Different, have the opposite sign. So what will happen? The electric field will be 0 near to the that charge which has the charge has small charge, right? So our point will be the point at which the electric field will be equal to 0, where that point is near to the small charge. So what the our electric field will be equal to 0, what? Near to the small charge, that is the minus 9 microcoulomb. So we have to find here the net electric field. Suppose this is the distance x, right? So due to this minus 9 microcoulomb charge, what is electric field? That is the k q1 by x r square, that is the k into 9 by x square. This is the electric field due to the 9 coulomb charge, 9 microcoulomb charge, right? Now the electric field due to what? Plus 16 microcoulomb charge, that is what? K q2 by r square, the k into 16 into 8 plus x ka whole square. So what is, since because of this the electric field is what? Towards left, and because of this the electric field is what? Towards right. So what is the E net? E net will be equal to what? E1 minus E2 is equal to 0. And by putting the value of E1 and E2, that is the now we will equal to, and after solving this we will get the value of x is what? 24 centimeter. This distance is what? From the 9 microcoulomb charge, right? So our first option is the correct option, right? Got it? Okay, very good. Now move to the next question. The question is that a 10 microfarad capacitor is charged to a potential difference of 1000 volt. The terminals of the charged capacitors are disconnected from the power supply and connected to the terminals of an uncharged 6 microfarad capacitors. What is the final potential difference across each capacitor, right? So how can you proceed for these questions? So first, when they are what? Connected, right? Connected like this one and parallel. So first we have to find the what is the equivalent capacitance. So if the capacitors are connected in parallel, so what is the equivalent capacitance? C is equal to C1 plus C2. Now put the values of C1 and C2, will get 16 microfarad. One more thing is that when they are connected in parallels, and what? There will be transfer of charges from high potential to low potential, right? And one more thing that the what is the, and the potential will be what? Till the potential will be same. Now we would like to find the charge on each capacitors. So we will the charge, here is the charge. The charge is stored in the first capacitor is what? Q is equal to C1 into V, right? In the first what? In the first capacitance. Now put the value of C1. So what is the C1? C1 is the 10 microfarad. So Q is equal to what? 10 to the power 6 microfarad. Now the potential difference across each capacitor can be calculated as V dash is equal to Q by C, right? Now we know the value of Q here, 10 to the power 4. It will be what? 10 to the power 4 microcoulomb, right? Not 10 to the power 6, 10 to the power 4. So you what? 10 to the power 4 by 16. So after solving this, we will get what? How much? 6 to 25 volt. So our third option is the correct options, right? Have you got this point or not? Yes, very good. Now we will move to the next question. The question is that in the figure C1 is equal to 10 microfarad, CT is equal to 20 microfarad, and C3 is equal to 15 microfarad. we have to calculate the potential difference across C3 is. So here there was again the same concept. Here again same concept, that is the parallel and the series combinations. We know that this is on what C1 and C2 is what in the parallel, right? So first we have calculated the parallel combinations, right? Now this CP is what now in series is what C3. Now we will again find, we have found got what the C equivalent. This is the final C equivalent, is what 10 microfarad. Now we will calculate the what is the total charge flowing through this one. Now this one is like that, right? This one is like that, okay, 12 volt, and this is what 10 microfarad. Now what is the total charge? It is what Kichel was C equivalent into V. So after solving, what we get? We get the 1200 microfarad. Now we get the value of Q. We know that the here the charge will flow, okay, Q, and after that here what there is a what the Q1 and Q2 will be goes there, and after at this junction what will happen? The charge will again Q1 plus Q2. Hence the charge, total charge across C3 is what will be same. So what is V3 is equal to Q by C3. So we know the value of Q and we know the value of C3. We will put the values and we got the V2 is equal to 80 volt. So our second option is the correct options, right? Now we will move to the next question. That is what question? That is the question is that what will be the flux coming out of any surface of a cube if a charge Q microcoulomb is placed at the center of the cube, right? So what is the question? Question is that like that. This is our one cube here, right? Cube. This is the cube, okay, and at the center of cube there is a charge Q, okay, Q, that is the Q microcoulomb. So we know the from the Gauss law what is the total flux through the closed surface, that is the Q enclosed by epsilon naught, and we know the value of what is the value of Q. Q is the Q, that is we get the what Q by, and we have to convert into what into the coulomb, that is the Q into 10 to the power minus 6 microcoulomb. This is the flux, total flux. So flux is what Q into 10 to the power minus 6 by epsilon naught. This is the what the total electric flux. Now we have to calculate the through the one phase, right? Through the one phase. So from the 6 phases, how many? This one is the what? And for finding the flux through one side, we have to divide by 6. So after solving this, what we have to do? We have to, it is the 5 dash is equal to what? 5 by 6. And after putting the value of this one, we get the Q by 10 to the power minus 6 by 6 epsilon naught. That is the our fourth option is the correct options, right? Okay, I think you might have understood the concept, right? Okay, now it's time for next question. The question is that what is the graphical representation of an electric field due to the uniformly charged sphere of radius r, which is the function of distance from the center? In this question there is a one mistake, that is the it is not mentioned that it is what conducting sphere or it is what non-conducting solid sphere. So here what this is the case of what non-conducting solid sphere, right? This is the non-conducting solid sphere, non-conducting, okay, and the total charge on this what, that is the rho density, you can find the rho. So inside this one at a distance of r, we know the electric field inside is the rho r by 3 epsilon naught when r is less than r. This is the inside of non-conducting sphere, right? So what we get? We get that the E inside the this non-conducting solid sphere, that is the directly proportional to what r, right? This is what r. So our diagram will be what this one, this is the straight line up to this. Now after outside of this one, what will be the electric field? So outside of this non-conducting solid sphere, that is the E out is equal to rho r cube by 3 epsilon naught r square. This is the question, right? So this is the what our electric field outside of this one. So what we get the outside of a sphere, the electric field varies with the radius of sphere as E out is equal to 1 by r square. This is the rectangular hyperbola. So this is what this is like that. So which option is the correct option? The second option is the correct options. Okay, I think you might have understand the concept. Okay, now come to the next question. The question is that consider two capacitances of capacity C1 and C2 which are connected in series and have potential difference V. What is the potential difference across C1? Right, now they are what? They are connected in series. So first we have to find the C equivalent, that is this one, right? Okay, now we know that Q is equal to what? Q is equal to CV. So what is the charge on this one? C equivalent into V. So what is C equivalent? This is what V into C1 C2 by C1 plus C2. This is what? This is our Q. Okay, this is our Q. Now we have to find the potential difference across this one. We know the value of Q. We can also find V is equal to what? Q by C. So we know the value of Q and we know the value of C. C is what? C1. So this is what, after solving this, we get V1 is equal to V2 into C2 by C1 plus C2. So our fourth option is the correct option. Okay, I think you might have understand the concept. Okay, now move to the next questions. Okay, students, one thing is that one point from my side is that you have to clear your concept. You must know about the basics formula, basic things, that what is going on here. Okay, if it is not clear, so before watching the videos you must go through your textbook, your notes, whatever you prepared, and then again come to this solution. Right, now it is the next question, that is an electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. Calculate the charge on the dipole if electric dipole length is 2 centimeter. So when you might have learn about, that is when the dipole is placed in the electric field, so what is the torque acting on this one? If the dipole is placed in uniform electric field at angle theta, so torque on V is equal to what? Pe sin theta. So by applying this one, we will try to solve our problem. This is what? P sin theta. P is equal to what? Q into distance, Q into L, right? This is the tau. P is equal to sin theta. Now we know the value of theta. We know the value of what? We have to find what? Dipole length. Okay, so Q is given here or not? Okay, we have to find the charge. Okay, so now what? Tau is equal to what? You know, P is equal to what? QL. So at the place of P we can add QL is sin theta. Now what is Q? Q will be what? Tau by LE sin theta. Now substitute all the values given in the question. What is the tau? Tau is the 4 Newton meter. Okay, divided by L. L is what? 2 centimeter. So we have to convert into what? Meter. Okay, electric field is what? 2 into 10 to the power 5 and angle is sin 30. So after solving this we get what? Q is equal to 2 millicoulomb, right? Q is equal to 2 millicoulomb. So our first option is the correct option, right? I think you might have understand the concept, right? Okay, if you not, then go through your notes, whatever you prepared. Okay, now move to the next question. If an electric dipole is placed in positive direction in a potential region V is equal to minus K by R, will it experience a force and torque? Right, so situation is something like that. This is the electric field, right? Electric field, and a dipole is placed in that electric field plus q and minus q. So what is the force on this one? The force on plus q will be right towards right, and the force on minus q will be what? Towards left. So what is the net force on the dipole? That is the 0. Now we have to find the torque. So we know torque is equal to what? P is sine theta, right? P is sine theta. Since the dipole is placed along the electric field, so angle is what? Angle is 0. So what is tau? Tau will be equal to 0. So one thing is that here the net force is 0, but there is a force acting on the dipole, right? So here torque is 0. So our third option will be the correct option, right? Okay, yes. Now move to the next question. The question is that in a non-uniform symmetric electric field given by E is equal to k by x square, where x is the distance from the source charge and k is the constant. A dipole of dipole moment P is placed at its center is r, distance from the source point. Calculate the force and torque experienced by the dipole. Okay, so here what we observe here, the electric field is what? Non-uniform electric field. So we know that the force on the dipole in the non-uniform electric field is F is equal to P dot delta A, right? So what is del operator? That is the dy Ex by dy x, dy y by dy y, and dy z by dy z, right? Now here only the electric field is along the x direction, so we have only differentiate, we have find the electric field differentiate this on what? Along the x axis. So after solving this, what we get? We get minus 2k by x cube. Now we have to find the force. So force can be given as that is P is equal to F is equal to P minus 2k by x cube. So what? There is a force acting on the what? On the dipole. Now here the what? Here is what? The angle between the angle here what? This is the electric field, and along this direction this is the dipole we have placed. So here the what is the angle between electric field and dipole? The electric field and the dipole is 0, right? Angle between electric field and dipole is 0. So what? With net torque will be equal to what? 0, right? So our second option will be the correct option. Now move to the next question. The question is that two uniformly charged spheres with radii r1 and r2 and the charges q1 and q2 are separated by a distance d. What is the magnitude of force on q2 due to q1, right? So what is the situation? The situation is something like that. This is the radius r1 and this is the radius r2, and distance between them is what? D. Okay, and the charge on this one is what? Q1, and the charge on q2 is q2. So what? We have to take the distance from the center, not from the surface, right? So what is the force between this one? So what is the force between this one? That is the F is equal to k q1 q2 by r square. So what is the here the total distance? We take the distance from the center. So this is what? R1 plus R2 plus D. This is the R. Now put the value of R and we get what? F is equal to K Q1 Q2 by D plus R1 plus R2 ka whole square. So our fourth option is the correct option. So you can look here. You must have knowledge about the basic concept of the what? Coulomb's law, right? Okay. Now move to the second next question. A thin spherical shell has charge on Q on it. The potential inside the shell is constant. The electric field inside the conductor is. We know that the relation between the electric field and the potential is what? Is equal to minus dV by dx. Now here is what? V is equal to 0. So if V is equal to 0, it means what? If we integrate this one, then what? V is equal to constant. Here is what? V is equal to constant, not 0. B is equal to constant. It means what? If we differentiate the constant, then what we get? We get the 0. So this implies that what? The electric field inside the conductor is what? 0. So our second option is the correct options, right? Okay. Now move to the next questions. The question is that a hollow conducting body is placed in an external electric field as shown in the figure, which quantities are 0 inside it. Okay, so before solving this question, you must know about what is the properties of conductor. What is properties? Properties conductor is that the electric field inside the conductor is always 0. One thing is that, and the charges always it resides on the surface. No electric field lines what enters into the conductor. This is the concept. Now apply this one. Since this is the conductor, so what we get? The electric field inside the closed surface is always 0, right? This is the properties of from the conductor. And also the charge always what? Resides on the what? Outer surface of the conductor. Okay. Okay. Hence there is no charge inside the hollow conductor. There is no charge now. So what? The charge density is what? 0. So our first option will be what? Equal to is the correct options, right? Okay. Now move to the next question. The question is that 8 charged drop of water each of radius 1 millimeter and having a charge of Q combine to form a bigger drop. Determine the potential and the charge on the bigger drop. Here is what? When the 8 drop will combine to form a bigger one, so what will remain same? The volume remains same, right? So first we have to find the what is the radius of the bigger sphere. So what we have to equate the volume of the both the sphere. Let's say this is the big one. So what is the volume of this one? 4 by 3 pi r cube is equal to what? We have to find the then what is the volume of 8 small spheres? That is the 8 into 4 by 3 pi r cube. So after solving this, we'll get r is equal to 2r. We get the what? Value of r. Now the charge on one drop is what? 10 to the power minus 10 coulomb. So what is the charge on the a drop? That is the 8 into q. That is the 8 into 10 to the power minus 10 coulomb, right? So we know the value of r, we know the value of q. Now we can find the also the what? The potential. So what is the potential in the bigger drop? It is V is equal to what? K q by capital R. So now putting the value of r from here what is 2r? 2r is what? Small r is what? 1 millimeter. So we get what? 2 into 1 into 10 to the power minus 3. So after solving it, how much we get? V is equal to 360 volt. So our second option is the correct option, right? So this is the basic idea, that is the you have to know about the what is going on here, right? So we should know about what is the potential on the surface of the conductor. You should know that is V is equal to what? 1 by 4 pi epsilon naught q by r. Now move to the next question. The question is that a parallel plate capacitor with a liquid filled with the plate's dielectric constant of liquid K is equal to 4, capacitance is 20 microfarad. If the liquid is removed, the capacitance of the capacitor becomes. Here is the condition, right? Here is the what? Dielectric is filled. So when the dielectric is filled, then what is the capacitance? The C is equal to epsilon naught K AK by D. D is the what? D is the distance between the plate, A is the area, right? So we know the value of the K, we know the value of 20. So we can easily find the value of epsilon naught A by D. Now if the the liquid is removed, then what is the capacitance for this one? The capacitance will becomes epsilon naught A by D, and we know the value of what? Capacitance of the value of epsilon naught A by D. Now putting the value of this one, and then we get CF is equal to 5 microfarad. So our second option is the correct options, right? Now move to the next question. The question is that if closed integral E vector dot ds vector is equal to 0 over surface, then we have to choose one correct options. Here is what is the flux? What is the mathematical definition of electric flux? Phi is equal to what? Integration E vector dot ds vector, right? If E vector dot ds is equal to 0, then what is the phi net? Phi net is equal to what? 0. So what does it means? It means the what? Whatever the field lines will enter the surface, all of them will leave them. The number of lines entering into the surface is equal to the number of lines coming out from the surface. This is the concept of it. This is what phi is equal to phi r. So number of field lines entering is equal to the number of field lines leaving the surface. So our fourth option is the correct option. Okay, so so solving this question, you must know about the basic idea about what is the electric flux, right? Now the question number 28, the question is that the angle between the electric lines of force and the equipotential surface is. We have to find the what angle between the electric lines of force and the equipotential surface. So before solving this one, before watching this, you must know about what is the equipotential surface, what is the properties of equipotential surface. This should know about this idea. After that you can solve this one. So what we that we know the relation between the potential and the electric field is what? dV is equal to integration minus E dot dr. Since we know this is the equipotential surface, so on the equipotential surface, what we observe? On the equipotential surface, electric there is no potential difference. Means what? The difference is potential is what? Always zero. That is what? dV is equal to 0. So this is what? Whole quantity will be equal to 0. So now we have taken the component E cos theta. So E cos theta what? E cos theta is equal to E cos theta dr is equal to 0. E and dr will not be equal to 0. So only what? Cos theta is equal to 0. And after solving this, we get what? Theta is equal to 90 degree. Right? So our what? Third option is the correct option. Also, you know, when we read about the equipotential surface, you know that is the electric potential surface always, electric field lines always makes the angle of 90 degree with the equipotential surface. This is the properties of equipotential surfaces, right? Now come to the next question, that is the 29th question. The three charges plus q and q are placed at the corners of the right angle isosceles triangle as shown in the figure. If the net potential energy of the system is 0, then find the value of k. We know the before solving this, you must know about what is the potential energy due to the system of charges. So what is there is a what? 3 charges, then what? K Q3 Q2 by R32 plus what? K Q3 Q1 by R31 and plus what? Plus K Q1 Q2 by R12. This is the formula for the 3 system charges. Now look here, we have designed here. So what we observe, that is the, if this is the A, this is the A, then what is the length of this one? This is the root 2A. Now then what is the net potential energy of the system is? That is the U is equal to kk square by A, and this one is the our value. Now we know that from the question is that what? U is equal to 0. Now we get this value equal to 0, and after this we solving q plus q by root 2 equal to 0, and after this we have found what? Q is equal to minus root 2q by root 2 plus 1. So our second option is the correct option, right? So this is the idea, you must know about this one. Okay, yes. Now move to the next question, the question number 30. The question is that 6 charges plus q minus q plus q minus q plus q and minus q are fixed at the corner of a hexagon of a side D as shown in the figure, right? The work done in bringing a charge q naught to the center of hexagon from infinity is. We have to find the work done. So work done in bringing the charge from infinity to that point. So we will use this formula, that is a q, W is equal to q v f minus vi, the potential at the final position and the potential at the initial positions. So since we are bringing the charge from infinity, so what will happen? At infinity the potential will be what? 0. So we have used this one, that is the v naught minus v naught. So V naught is what? At infinity what? It will be 0. But what will be the potential at this point? Tell me. The potential at this point will be what? This distance will be d, 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 and this is also d, and this is also d. So now 1, 2, 3. This one is the what? Same potential. So we will write here 3kq d by 3kq by d. Now for minus q, minus q, minus q. So what we have done? Minus 3kq by d into q naught. So after solving this, we will get what? Work done is equal to 0. So our second option is the correct options, right? Okay, I think you might understand the concept. Okay, now come to the next question. 2 point charges q1 and q2 are placed at a distance d apart as shown in the figure. The electric field intensity is 0 at a point P on the line joining them as shown in the figure. The ratio q1 by q2 is. You know that, friends, which concept we are being to use here? That is the electric field due to point charge. So what is the electric field due to point charge? That is the kq by r. This concept we are being to be used here. Now what is this here? There are two charges q1 and q2. Suppose this is the distance is r, right? Let us first find the directions of the electric field due to q1 and q2. Due to q2, what is the direction of the electric field? Towards right, that is the E2. And what is the direction of electric field due to q1? It is also what? Towards right. So both are what? Same directions, right? Okay, so now we have to find the what? The electric field due to point charge q1 due to at P. So this is what? K q1 by r1 square. And what is the r1? R1 is equal to what? D plus r by 2. D plus r. Okay. Now what is r2? R2 is the distance between charge q2 and this one. So this is what? K q2 by r2 square. Now what we have done here? Now these are what we have from the question. What is that? At point P is what? Electric field is 0. So we get E is equal to minus E2. So after that we get what? Q1 by Q2 is equal to minus R1 by R1 square by R2 square. Now what is the value of R1? R1 is the what? R plus D. So it is R plus D. And what is R? R2 is R. So after putting this value in the equation, we get Q1 by Q2 minus R plus D square by R square. So our first option is will be the correct options, right? I think you might have understanding all this, okay, these concepts. Now come to our next question. That is question number 32. What is the question? 4 concentric conducting spherical shell P, Q and R of radii A, 2A, 3A and 4A respectively. Shell P and S are given charge Q and minus Q respectively. If shell R is grounded, then potential difference Vp minus Vr, where Vp and Vr are potential at P and R respectively, right? So what is the situation given here? The situation is something like that. This is the sphere, you can say this is the P. This is the sphere Q. This is the shell R. And this is what? This is the upper, what is what? This is the S. So what is this one? The question is from the question, what is it given? This R is grounded. So grounded means what? The potential of the shell will be equal to what? It will be equal to 0, right? This is the given. And the charge and P and S are given. The charge and P is what? Q, and the S is what? Minus Q. We don't know the charge on Q and we don't know the charge on what? R. So let us suppose this is the value of the charge on P1 is what? Q1. The charge on Q is Q2. The charge on Q3 is Q3, and charge on Q QS is Q4. Let us say, okay, given here, okay, Q1, Q2, Q3. So we have given what? The charge on P1, Q is what? Q1. Q1 is what? How much Q is given? And on the Q2 there is on the Q there is no, there is what? Q2 is equal to 0, and we have to find the Q3, and Q4 is what? Minus Q. And what is the R1? This is the R1, this is the R2, this is the R3, and this is what? R4, right? R1, R2, R3, R4, this is going A, 2A, 3A and 4A. Now we will find the value of potential at R, because we have to find the value of Vp, and for that one we don't know about the value of Vp. So first of all, let us find the value of charge on this one R. So what we have, find the potential or the shell R is given a kq1 by 3a plus kq3 by 3a plus kq3 by 3a plus kq4 by 4a. Now after grounding, the what, the potential is equal to 0, then after solving this we get what, q3 is equal to q by 4, right? Now we have find the value of q3. Now it's time to find the value of Vp, the potential P, because we know the value of q3. Okay, we know the all the values q1, q2, q3, 4. Now find the potential at point at the shell P. That is what, kq1 by a plus kq3 by 2a plus kq3 by 3a plus kq4 by 4a. Now after putting the values and this solving, we get what, we get Vp is equal to 2kq by 3a. So after we know the value of k is what, 1 by 4 pi epsilon naught. Not we have to find what, Bp minus Vr. So Bp minus Vr is what, 0. Now but after putting the one value of k, we get what, 2q by 4 into 3 pi epsilon naught a. After solving this we get what, q by 6 pi epsilon naught a. So q by 6 pi epsilon naught a. The second option is the correct option, right? This is the concept that we have to apply here. Now move to the next question. The question is that the equivalent capacitance of the arrangement shown in the figure. We have to find the equivalent capacitance. So here suppose this is the what, C1, this is C2, this is C3, this is 4. So what we observe, this one and this one, this is C2, C3 and C4 are in series. So first we have to find the equivalent capacitance of C2, C3 and C4. So we haven't used, after putting the value we get what, CS is 5 microfarad. Now this CS is what, now this CS is now the in the parallel with the what, in parallel with this one, right? In parallel of this CS, and C1 is what, in parallel of this one. Now we have to find the equivalent capacitance of this one. So then what, we have to find C equivalent is what, C1 plus CS. CS you know the value of 5, and after solving we get what, how much, 20 microfarad. So our fourth option is the correct options. Here is nothing but what we have to use, we have to use the series and parallel combination of the capacitance, right? Now move to the next question. The question is that in a certain region of space, the electric field is along the z direction throughout. The magnitude of the electric field is, however, not constant, but increases uniformly along the positive z direction at the rate of 10 to the power 5 Newton per coulomb per meter. What is the torque experienced by the system having a total dipole moment equal to 10 to the power 7 coulomb per meter in the z direction? Here we don't know the angle between the dipole moment and electric field. Okay, you know that is for finding the torque with the formula is what, tau is equal to P sin theta, but we don't know the direction of the angle between the dipole moment and the what, and the electric field. So now first we will find the angle between the what, dipole moment and the electric field. So what is given in the question? So P is what, Q into dl, and P is given, that is a minus 10 into 10 to the power minus 17 meter. Here let not be the minus 70, this is what, minus 7, okay, minus 7 coulomb meter. This is the given, 10 to the power minus 7 coulomb meter, right? Minus is what, because is the what, towards the negative z directions, right? Means this is the direction of electric field in the positive z direction, and towards the negative z direction is what, there is a dipole moment. So, and so that's why what, this is a minus 10 into minus 7 coulomb meter. Now the rate of change of electric field is what, 10 to the power 5 Newton per coulomb. That is the dl by dl is called what, 10 to the power Newton per coulomb per meter. Now we know the F is equal to what? QE. Now put the value of QE is what we have adjusted, that is the QE by DL into DL. So this Q into DL is what becomes what? P. So P is equal to what? DL by DL. We know the value of P is what? Minus 10 to the power minus 7, and what is the D by DL? That is the 10 to the power 5. After solving this, we get what? F is equal to minus 10 to the power minus 2. So what we observe, that is the force in the negative Z direction, and this is what? Opposite to the direction of electric field. Therefore, the angle between electric field and the dipole moment is what? 180 degree. Now we will use the formula tau is equal to P sin theta, and put the value of theta, we get tau is equal to 0. So our second option is the correct options, right? Okay. Now move to the next question. The question is that two parallel infinite line charges with linear charge density lambda coulomb per meter and the minus lambda coulomb per meter are placed at a distance of 2r in free space. What is the electric field midway between the two line charges? First of all, tell me what is the electric field due to infinite charge rod? That is the E is equal to what? Lambda by 2 pi epsilon naught r. R is what? The perpendicular distance from the infinite part line charge. This is the formula for the electric field due to infinite charge. By using this formula, you will try to solve. So what is the condition here given? This is the two line charges given here. This is one, okay, and this is the distance. This is the distance r. This is distance r, right? 2r. The distance between them is what? 2r. Now we have to find the electric field at this point. So this for first one and second one. So first one, what? What is the electric field? Electric field is what? Lambda by 2 pi epsilon naught r. And for second one, what? How much? Is equal to E1 is equal to what? Lambda by 2 pi epsilon naught r. One thing is that here we have to observe that this is a positive charge and this is a negative charge. So due to this, the electric field is what? Here towards right, and this is also this. Here what? The electric field also what? The towards right. So what is the net electric field? We have to add them. This is the E net. So now putting the value of the E1 and E2, we get the E net is equal to lambda by pi epsilon naught r Newton per coulomb. So our which option is the correct option? Tell me. The option third is the correct options, right? So this is the some concept that you should know about this one, okay? Now it is what? It is section B, and we move to the next question, the question number 36. Let us first read the question. A parallel plate capacitor is connected to a battery as shown in figure. Consider the two situations is given here. Key K is kept closed and plates of capacitor are moved apart using insulating handle. And the situation B is given here. The key K is opened and the plates of capacitors are moved apart using insulating handle, right? So we have to tell about the charge will change, or capacitance will change, or voltage will change or not. That's we have to find this one. So first we'll discuss about the case 1. Here what will happen? The K is what? Closed, and we have to what? We have to separate the plates. So what is the capacitance of a parallel plate capacitor? That is what? Epsilon naught A by D. So what? D is what? Increasing. So what? C will be decrease, right? This is the, then first one is what? The C capacitance will decrease. Now here the what? The battery is connected. This means what? V remains same. So V will be constant. Okay. But we know Q is equal to what? Q is equal to CV. So C is decreasing. So that's why what? Q will also decrease. Okay. This is the for case 1. Okay. So hence charge also be decreases. Now for the case 2 is what? So case 2 is what? The K is opened, right? Opened. After charging capacitor, the K is opened. Now what will happen? The charge will remain same. because whatever the charge capacitors have, so after disconnection from the battery, what will happen? The charge will remain same. This is the first condition. Now, so what in this condition, what? Q remains same. Okay, that is the conserve. Now, when we separate this capacitor, parallel capacitor like this one, then what happened? The distance is increasing. So if distance is increasing, what? So C is what? C will decrease, right? Okay, so what? Capacitance will decrease. So we know that Q is equal to what? Q is equal to CV. So what is V? V is equal to Q by C is equal to V is equal to what? Q by C. So C is increasing, then what? V is what? Increase, right? So our third option is the correct option, that is in A V remains same and hence Q is changes, right? This is the concept about the question number 36. Now move to the question number 37. Okay, so question number 37 is that what? 2-point charges plus Q and minus Q are fixed at minus d comma 0 and d comma 0 respectively of an xy coordinate system. Then, so this is a system that we have placed the two charges, that plus Q and minus Q. Suppose the first one was electric field at all the points on the y-axis along y. Suppose this is a y, upper y. So when we find the direction of electric field, so electric field due to plus Q is what? Towards this one, and electric field due to minus Q is towards this one. So what is the net electric field? The net electric field always towards the positive x-axis. Now suppose the point is here. So now please tell me the electric field due to what? This one, this one, and for what? The electric field due to minus Q is what? About this one. So what is the net electric field? Towards right. So we have to choose one correct option. So which option is the correct option? Our first option is the correct options, right? Okay, now move to the next questions. Now let us first discuss our 2 and 3rd and 4th options also. Let us check in question number 37. The electric field at all point on the x-axis has the same direction. Okay, let us check. Suppose this is our x direction, right? So electric field due to this is what? Minus Q is what? Towards left, and electric field due to what? This one is towards right. So what is net electric field? Towards left, right? This is the innet. But when this here, what is the electric field due to this one? Towards this one. And what is electric field due to minus Q? Towards right. So what we get? The net electric field towards the right. Here the net electric field what? Towards left. Here the what? Electric field, net electric field what? Towards right. So this option 2 is not correct. Now what? Dipole moments is 2qd and directed along minus I. No, because the dipole moment, what is the direction of dipole moment? It is always from negative charge to positive charge. So this is a negative charge, this is what? Positive charge. So this is the direction of the what? Our dipole moment. So this is also wrong answer. And work has to be done in bringing a test charge from infinity to that origin. Here if you want to find the potential at this one, so what is the potential at the origin? It will be equal to 0, and we know that already that the potential at the infinity is what? Infinity is what? Always 0. So V is also V initial was 0. So what is the work done? Work done is equal to Q into Vf minus Vi, and that is what? That is equal to 0. Means there is no work done has to be done when the test charge is carries from the infinity to that point. So this is also not the correct option. Only first option is the correct option, right? Now move to the next question, that is question number 38. Let us first read the question. A proton is accelerated from rest through a potential of 500 volts. Its kinetic energy is, we have to find the kinetic energy. Okay, so what is the kinetic energy? The decrease in potential energy is the what? Increase in kinetic energy. Decrease in potential energy what equal to what? Increase in kinetic energy. So if you want to find the what? Kinetic energy, so we know the potential difference between A and B is what? 500 volt. So first of all, we what we will calculate? We will calculate changing the potential energy. So this is what? Q is equal to what? Minus 5 electron volt, because this is what? Electron. So for electron, what? This is the minus Q, that is the 500 electron volt. Here is what? Here is a decrease in what? Potential energy. So this is what? This is the what? This is the this is what? Equal to the change in the increase in the kinetic energy. So this is the what? Kinetic energy, how much? The 500 electron volt. So our second option is the correct option, right? Now move to the second next question, that is the question number 39. In the given figure arrangement of parallel plate, each plate has area A and the distance between two consecutive plates is D. The equivalent capacitance of the system between X and Y is given as. This is the this one and this one. This is C1, C2, C3. Okay, three capacitors are given here. So first of all, let us rearrange this one. After rearranging, what we get? We get this one and this one. Okay, 3C, C is what? C is here, we have given here 3C means what? C is what? C is the epsilon naught A by D. Okay, and we know the C is what? KC naught. C is what? KC naught. Okay, question to what? The if you want to find the with the dielectric constant, then what? We get the Kc into C. This is the with the dielectrics, and this is what? Without dielectrics, right? C is equal to epsilon naught A by D. Here C is what? Epsilon naught A by D. Okay, C is equal to what? C is equal to epsilon naught A by D. So for this one, what we have given? 3C. For this, what we have given? 6C. For this, what we have given? 2C. So what we observe? This is the 3C and 6C are in the series. Okay, this both are in series. And 2 is what? 2C is what? In the parallel of the both. So first of all, find the equivalent of this one. So this one is series and this is the parallel. Then our C net is equal to what? 3C into 6C by 3C plus 6C plus 2C. After solving this, we get the 4 coulomb charge, right? 4 coulomb charge. 4 coulomb, not 4 coulomb charge. This is the 4C. C is the what? Capacitance in the air, in the medium. So now put in the value of C. C is equal to what? Epsilon naught A by D. So what is the C net is equal to? 4 epsilon naught A by D. So our fourth option is the correct options, right? So this is the one concept that we have to be apply here. Now come to the our next question, that is the question number 40. What is the question? The question is this: 3 point charges plus Q minus 2Q and Q are placed at point x is equal to 0, y is equal to a, z is equal to 0, and x is equal to 0, y is equal to 0, z is equal to 0, and x is equal to a, y is equal to 0, z is equal to 0 respectively. The magnitude and direction of the electric dipole moment vector at this charge assembly are. So let's first we draw the diagram x, y, z, and we have put the charges here. Now we assume that this is the minus 2Q, there are two charges, minus Q and minus Q, right? Minus Q and minus Q. So for this one and this one, there is a one dipole moment. For this one and this one, what? There is a another dipole moment. So for this one and this one, what? This is the dipole moment for this one. For this minus charge and for this plus Q charge. This is the, let's say this is the P1, right? Px, you can say Px. And for this one, what? For this one charge and for this one wire, this is the along this direction, what? This is the P2 dipole moment charge. Okay, now we'll here is what? P2 along the positive y-axis, and the P1 is what? P2 is, this is the P2, this is the P1, suppose. Okay, and what is the P1? P2 is what? P2 along the, this is wrong, this is the positive. Okay, positive x-axis. This is the P1, this is the P2, because you have it is given here P1 and P2, right? Now we will find the P1 and P2, right? P1 and P2 is what? Have the same magnitude, because the distance is same. So that is the P1 and P2 is what? Almost equal to Q into A, that is the QA. Now what is the P net? P net is called what? P1 plus P2, that is the QA I cap plus QA J cap, because P2 is along x-axis and P1 is what? Along the y-axis. That's why this is the I cap and J cap. Now we have find the what? We have find the magnitude. So after finding the magnitude, what we get? We get root 2 Q square A square, and that is the root 2 QA. This is the P net. Now we have to find the what? the angle with the what x-axis, that is the theta is equal to 45 degree, making 45 tan is equal to what q by qa. After solving this we get what theta is equal to 45 degree. So this is the our p net is the root 2 qa and angle is what 45 degree, right? So please tell me which option is the correct option. Our second option is the correct options, right? So these are some ideas about the dipole moment. Now move to the next question, that is the question number 41. What is the question? The question is that the field lines are corresponding to an electric field shown in the figure, then E denotes electric field, V denotes electric potential. Now the question is that you know that there is a the strength of electric field lines increases if the density of electric field lines are greater. What we have observed at this point and this point, the electric lines of force density is what equal, but here it is not equal. So electric field A and electric field at C will what equal, and at B is what the density of electric field lines what less. That's why the E is equal to EC and greater than EB. Now we know that the electric field lines always travel from what high potential to low potential. So so A has the highest potential, B is the potential less than the point A, and C is has the potential less than the point B. So this is the VA greater than BV greater than BC. So our second option is the correct option. Okay. So this is some ideas about the electric field lines concept. I think you might have understood the concept, right? Okay. Yes. Now move to the next question. The question is the question number 42. The ratio of the electric flux linked with shell A and B in the diagram shown below is. Here is the diagram and we have to find the electric flux. So what is the formula for electric flux? From the Gauss law we know that the flux is called what? Q enclosed by epsilon naught, right? Suppose this is a and this is a B. So what is the phi A? So what is the phi A? Phi A will be equal to how much? Tell me. The phi A will be equal to how much? Q by epsilon. Because the what? Inside the A, how much charge is there? Only Q charge is there. That is the phi is equal to Q by epsilon naught. Similarly, the charge enclosed by B is, what is the charge enclosed by B? That is the also Q. That is the Q by epsilon naught. So now the ratio is now calculated as phi A is equal to phi B. So that is the 1:1 ratio. So our first option is the correct option, right? Okay. Okay. Now move to the next question. That is the question number 43. The question is that what is the electrostatic potential energy of a system containing two charges 40 nanocoulomb and 60 nanocoulomb at a distance of 30 centimeter. So dear friends, please tell me what is the potential energy of the two charge system. That is the U is equal to K Q1 Q2 by R. Now we know the value of K. K is what? 1 by 4 pi epsilon naught. What is Q1? Q1 is the 40 nanocoulomb. So we have to what convert into what coulomb? That is the we have to multiply by 10 to the power minus 9. Now after putting this one, we get the value of U is equal to 216 into 10 to the power minus 5 by 36. After solving this, we get the U is equal to 60 microjoule. So our second option is the correct option. This is a simple thing, right? This is so simple, right? Okay. Now move to the next question. That is the question number 44. So what is the question? The question is that the charge on each capacitor shown in the figure and the potential difference across them will be respectively. So please tell me what is the concept behind this? Please tell me. Yes, very good. That is a series and parallel combination, right? So first we have to find the what? The equivalent capacitance of this one, and then again the equivalent capacitance of this one. You know the 2 and 4 is what? In the series. What? 2 and 4 is what? In the parallel. So we have find the equivalent is 6 microfarad. Now, okay, this is what? This is a 6 microfarad and this is what? 3 microfarad. Okay. Yes. So now what is the equivalent of this one? This is a series, so we have found the equivalent of this one, that is what? C is equal to 2 microfarad. Now we know the value of, now all we know the we know the equivalent of the whole, that is the C is equal to what? 2 microfarad. So what is the total charge enclosed by this one? Q is equal to C into V, that is the what? 240 microcoulomb. So what is the charge? Now the potential difference across the what? First capacitor is can be calculated, that is we know the charge, that is the V1 is equal to what? Q by C1, that is the 80 volt. This is the voltage across the what? The C1. Now we calculate the potential difference across C2 and C3 for C dash, right? We know the equivalent of C2 and C3 is what? C dash, that is the 6. So we know the what is the total charge? 240. So 240 was 40 joule, right? So V2 is what? 40 joule, and V3 is what? Hence V3 is what? 40 volt. Okay, 40 volt. So V1 is how much? Tell me. V1 is how much? V1 is the how much? 80 volt. And what is the V2? V2 is the what? Tell me. 40 volt. Okay, 40 volt. Now the charge in the C2 is can be calculated as C2 by what? C2 into V2. We know the value of C2 is what? 2 into 40, that is the 80 microcoulomb. And similarly the charge in C3 is what? C3 is equal to what? C3 V3 is equal to 4 into 40, that is the 160 microcoulomb charge. So please tell me which option is the correct option? Our first option is the correct options, right? Okay, these are very simple, that is a series and parallel combinations, right? Okay, now move to the next question, that is the question number 45. A dipole is placed in a uniform electric field. Explain why the dipole charges experience a force but no net translation motion, right? So this is our dipole. Okay, when you placed in the electric field, the what? The force on the plus Q is F is QE, and force on this is what? Minus Q. Okay, there are two forces acting on the dual. They are what? They are the equal, but they're the opposite direction, you can say. So what is the net force acting on this one? The net force acting on this what? 0. That is F is equal to what? QE and minus QE, that is equal to what? 0. Since there is no net force acting on the dipole, that's why the what? Translation motion is equal to what? There is no net translation motion, because there is no net force acting on this one, right? So which option is the correct option? Our first option is the correct. Second option is the correct option, that is the no resultant force is available for the system. That's why there is no net translation motion. Okay, I think you might have understood the concept, right? Okay, now move to the next question, that is the question number 46. The question is that what? Two identical spheres carrying charges minus 9 microcoulomb and 5 microcoulomb respectively are kept in contact and then separated from each other. This is the two charges, two sphere. Okay, this is the minus 9 microcoulomb charge, and this is the what? 5 microcoulomb charge. Now what we have done, we have touched each other. So whenever they are kept in contact, so what will happen? There is a transfer of charges will take place. Okay, what? There is a transfer of charge take place. So what is the total charge of the system after connection? That is the 4. Since the both are identical, so we have to what? Divide by 2. So each sphere has a charge of minus 2 microcoulomb charge. Okay, now we know, now we have the value of what? Q. So Q is equal to what? Ne. Now we have to find the N is equal to what? N is equal to QIE. So now putting the value of Q, and you find that is the N is equal to what? Q is equal to what? Minus 2 into 10 to the power minus 6 by 1.6 into 10 to the power minus 19 coulomb. So after solving this, we will get what? N is equal to 1.25 into 10 to the power 13 electrons. So what? As excess in the each sphere. So our second option is the correct options, right? Okay, this is a very simple, that is what? Q is equal to any concept, and that is the what? One more concept is that was charging by conduction. These are two concepts that we have to apply here. Now come to the our cases. Now our next question, that is the question number 47. The question is that 4-point charges are placed at the corner of a square side as shown in the figure. A charge q is placed first from P1 to P2, then charge P1 to Q P3, then work done in displacing the charge. Here the plus Q charge, here the also plus Q charge, here minus Q charge, here what? Minus Q charge. So what we have done? The charges were from P1 to P2. This is the P1 and this is what? P2. This is the point P1, okay? This is the point P2 and this is what point? This is the P3. So what is this one? The charge Q is placed from P1 to P2. So when the charge Q is placed at P1 and P2, then the force will be same, right? When you place the charge Q, so due to all the charges, the force at P1 and due to all the charges force at P2 will be same. So we will directly apply the work done is equal to force into displacement. So this is the whole is A. So this is what? This is A by 2. This is the A by 2. So what is this distance? This is the A by root 2 distance will be there. Okay. Now we will use this formula directly. Work done is equal to what? Force into displacement. That is the what is the force? K Q by A by root 2 ka whole square, root 2 whole square into A by root 2, right? Okay. So after solving this, what we get? We get Q by A by root 2. Okay. So this is the work done from point 1 to point 2. Now the charge is from what? Taken from where? From P1 to P3. So here from P1 to P3. So what is the displacement at this time? The displacement will what? A. Okay. And what is the force? Force will be KQ by A square. For this one, what is the force? What is the force will be the KQ square. And displacement is how much? Displacement will be A. So after solving this, how much we get? KQ by A. So from 1 and 2, what we observe? The from 1 and 2 we observe that is the work done from 1 to 2 is much greater than from work done from 1 to 3. So our fourth option is the correct options, right? Okay, these are simple things that is we have to apply the what the work done concept, that is the force into displacement. Now come to the next question. The question is that an electron is released from rest in uniform electric field of magnitude 5 into 10 to the power 4 Newton per Coulomb. If the electron accelerate through a potential difference of 100 volt, calculate the distance it travel before reaching this potential difference. So in this question, simply we will use E is equal to minus dV by dr. Okay, dV by dr. So we have to see here was potential is constant, electric field is constant. So directly we will use what? E is equal to R is equal to V by E. Now we know the value of V. Now we know the value of V 100 volt and we know the value of E, that is a 5 into 10 to the power 4. After solving this, we will get R is equal to 2 into 10 to the power minus 3 meter. Okay, 2 into 10 to the power minus 3 meter. So our first option is the correct option. Okay, this is a very simple things. We have to only apply the what E is equal to minus dV by dr. Now move to the next question. The question is that if a unit test charge is taken from one part to another part over an equipotential surface, then what is the change in electrostatic potential energy of the system? We know that the electrostatic potential at the equipotential surface is what? Constant. There is no change in electric potential. Okay. So what is the work done? Work done is what? Q Vf minus Vi. So the Vf is V also and Vi is also a V. So after solving this, what do you get? Work done is equal to 0. Hence the work done in this process is what? How much? 0. So our second option is the correct option. Here the what? The properties of equipotential surface is used here. Now come to the question number 50. A point charge Q is placed at the center of the open face of a hemispherical surface as shown in the figure. The flux linked with the surface is. Okay, so we have to find the what? Electric flux. So what we do for this one? We will do, that is the, suppose we will make a full sphere. So full sphere, what is the phi? What is the phi for the full sphere? That is the Q by epsilon naught. This is the electric flux through the full, this is the full sphere. Now what is the electric flux through the half spherical hemisphere? That what we have to what? So what is the new flux? That is the what? 5 by 2. So we have to multiply by 2. So we get what? Phi is equal to 1 by 2 into q by epsilon naught. So we'll get the phi is equal to q by 2 epsilon naught. So our second option is the correct option. Okay. So dear students, we have done all the 50 questions that is the asked in BPT2, that is BPT2, that is the Brahmastra past test 2, right? So please go through this one again and again and try to solve by yourself. Okay, I think you might understand all the questions that is discussed here. Thank you so much.